Okay, more reactions. Get rid of this second here. All right. A solution of sodium bromide is added to acidified solution of potassium bromate. First of all, I see sodium here, I see potassium here, spectator, so I know I'm not dealing with this. So right away, I can write down bromide. I can write down bromate. And then an acidified solution. Always a tip-off that this could be a redox reaction if they're talking about the solution be acidified or basic. Remember, redox reactions you generally require either hydrogen ion or hydroxide. So we're going to put some H plus in here. So now, bromine, bromide. Bromate is a good oxidizing agent. Bromide gets oxidized to bromine. Okay. And we're going to get also some H2O. Now, this is a redox reaction. Outside the box, you might break it up into half reactions to balance things. And so, for example, 2 bromides are going to go to bromine. So maybe I'll do that up here. 2 bromides are going to go to bromine plus 2 electrons. So there's the oxidation. Bromide is being oxidized to bromine. The oxidizing agent is bromate. Bromate is going to Br2. Okay. The 2 here to balance the bromines. Now I need to balance the oxygens. So I need 6 waters to do that. I now need 12 hydrogens over here to balance out the hydrogens. And then finally, I've got 12 pluses, 2 minuses. I'm going to need 10 electrons, right? All right, that balances it out. Now, in order to bring these 2 reactions into balance, I've got one reaction that requires 10 electrons. I've got another reaction that requires gives off 2 electrons. So what am I going to have to do here? Okay. So if I want to balance these 2 reactions, I'm going to have to multiply this one by 5. Okay. I'm going to have 10 bromides plus 2 bromates plus 12 hydrogen ions reacting to produce 6 bromines and 6 waters. All right. When I look at that, I suddenly realize that I've got a common factor of 2, so I can divide everything by 2. So this is going to be 5. This is going to be 1. This is going to be 6. This is going to be 3. And this is going to be 3. Okay. Write the balanced half reaction for mass. The reduction half reaction. The reduction half reaction is the one we have up here. 12H plus 2 bromates plus 10 electrons goes to bromine plus 6 waters. Again, that's the reduction. Reduction means gaining electrons. All right. We also wrote the oxidation half reaction up there. All right. This is definitely redox. Aluminum metal is added to a solution of copper 2 chloride. Aluminum metal. Okay. Anytime you're starting with a metal, indication that some kind of a redox reaction is going to happen. Copper 2. Again, chloride is going to be a spectator. In this case, pretty simply, aluminum is going to go ion. Copper is going to be reduced to copper metal. Okay. There's our reaction. If we want to balance it, what do we need to do? All right, got to have the charge balanced. Got to have the charge balanced, and so in order to balance the charge, we have a 2 here and a 2 here. Got to have a 3 here and a 3 here. All right, that's redox. This is the 2 observations that indicate a chemical reaction is occurring. Okay, let's see. Aluminum disappears. Okay. Copper forms. Blue solution containing the copper plus 2 goes colorless. Okay, so there's 3 observations. Okay, there's 3 observations. All right. Again, another example of redox. Excess chlorine gas is passed over hot iron filings. Hot iron filings. Fe plus Cl2. So your guess. You know that iron can form either plus 2 or plus 3. If iron forms plus 2, you're going to say Fe. Cl2 is your product. If iron forms plus 3, then you're going to say it's Fe. Cl3. In order to balance those, the first reaction is balanced. In the second case, I'm going to need to put a 2 here, a 2 here, and a 3 there. All right, either one of those would be acceptable. Okay, either one of those would be acceptable, and this would be called a synthesis reaction. It's also a redox reaction. Okay, so there are a couple possibilities there. Okay, so synthesis and redox. Again, another indication, starting with a metal, okay, element, figure out redox. Magnesium metal is added to nitrogen gas. All right, Mg plus N2 reacts to form ionic compound. Magnesium is going to be plus 2. Nitrogen is going to be minus 3. So we're going to get Mg3, N2, magnesium nitride. What is the oxidation of magnesium before or after? Magnesium goes to magnesium plus 2 electrons. Oxidation number is 0 here, and it's 2 there. Okay? All right. Another redox reaction. You could also call this a synthesis reaction. Okay. 4 more done. Gosh, this is fun.